Okay, hi everyone. Today we're going to be trying something a little bit new, and we're using this website called Edpuzzle. The benefit of Edpuzzle is it's going to allow me to get a little bit of feedback from you, and it's also going to allow you to try and answer some questions, and I can kind of see directly what your answers are, as opposed to the regular videos where I don't actually know if you're watching it or how you're doing with the questions. So we'll try this for a bit, and if we need to reevaluate, then we'll do that a little bit later on. Today, we are starting our last unit. So it's unit 7, our last final unit of Algebra 2, and it's all about trigonometry. Now, today's first lesson and a couple lessons later on are going to be mostly review from things that you would have learned either last year in geometry or possibly early this year in geometry. But hopefully, all this won't be too unfamiliar for you. So in general, we're going to look at the idea of trigonometric functions. And for now, we'll look at in right triangles. Now, in the past, you may have heard them called as trigonometric ratios, but our goal in this course is we're going to look at kind of combining the idea of trigonometry with the graphs and the functions that we've seen so far in this course. So if you can think about what we've been doing in each of our units, where we often go through and we look at characteristics of functions, or we look at graphs of functions or transformations, and we solve equations, we're going to kind of do the same things, but we're going to do it involving trigonometry. So our goal today is to look at finding values of trigonometric functions or ratios for acute angles, so angles of less than 90 degrees. And we're going to use trigonometric functions to find side lengths and angle measures of right triangles. So our goal for today is focusing on right triangles. In general, trigonometry is the study of relationships among the angles and sides of a triangle. But we can look at other aspects of trigonometry as well. We will say that a trigonometric ratio compares the side lengths of a right angled triangle, and a trigonometric function has a rule given by a trigonometric ratio. Now, I mentioned the word trigonometric a lot, but you can kind of just think for now-ish of trigonometry as relating to triangles, but that's not entirely true. Now, here we have a right angled triangle, and we're going to denote that this is a right angled triangle with this square corner here. And we're going to use this symbol here. And this symbol here is actually the Greek letter. It's kind of like a 0 with a kind of curve inside. This is actually the Greek letter. It's called theta. And in both mathematics and in science, theta is often the letter or the variable, I suppose, that we use when we relate to an angle. Now, you can use any letter you want. You could use x, for example, but most often we use the letter theta. So I'm going to be using theta a lot. And when it comes to a right angle triangle, we label the three sides based on where my angle is. My longest side of a triangle, or it's the side that is always across from the right angle, this is always going to be called my hypotenuse. So no matter where my angle theta is, whether it's here or whether we call this one up here theta, my hypotenuse is always the longest side. Then we look at the side that is attached to my angle. So we see this angle here is made between two lines. One is my hypotenuse, and the other one here, the one that's closest to my angle, is always called the adjacent side. Adjacent meaning right beside. And lastly, the one that is across from my angle theta, or opposite, is called the opposite side. And the idea is that hypotenuse and opposite, or hypotenuse will always stay the same, but depending on where your angle is, the adjacent and the opposite side could change. So for example, if my angle theta was up here, then that would mean that this now becomes my adjacent side, and this now over here becomes my opposite side. It depends on where we consider the angle to be. And we can look at three primary trigonometric ratios based upon where my angle is. So if you can recall from geometry, we have these three different ones. And the first one here we'll call is sine, or we use SIN when we use it in terms of mathematics, but SINE is sine. And so we would say that the sine of theta is a ratio of different sides. And the ratio here is going to be my opposite side, or op, divided by my hypotenuse side in terms of the length. And that's always going to be the case. We would have that my cosine of theta is the ratio is always going to be my adjacent side divided by my hypotenuse. And lastly, we'll have up here, we have that my tangent of theta or tan of theta is always going to be my opposite divided by my adjacent. And if you can recall from geometry, we have kind of a 9-letter word that we use to kind of remember this. And our 9-letter word is SOHCAHTOA or SOHCAHTOA. SOHCAHTOA. And the idea behind this is it breaks it up into 3 letters, and this is meant to help us remember. So we can say here that my sine, we look at the letters, my sine is equal to my opposite O divided by H, my hypotenuse. We can see over here that my cosine is equal to my A adjacent divided by my H hypotenuse. So we can see here we have CAH. And lastly, we have my tangent here, which is going to be equal to my tangent is my opposite divided by my adjacent. So my tangent is my opposite divided by my adjacent. And this is just something that we can use to help us remember. We also have these things which are called reciprocal functions, which is 1 over. So for example, we can see here that my sine of theta is my opposite over my hypotenuse, but we have this kind of the inverse or the reciprocal. So if we were to do 1 over sine, for example, this would be equal to my cosecant of theta. So we can see we go from opposite divided by my hypotenuse to hypotenuse divided by my opposite. In general, these 3 here are called my primary trig functions, and these 3 here are called my reciprocal trig functions. So right here, these are often called my reciprocal. The idea reciprocal being kind of 1 over. So cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. So let's go ahead and use this. Here it says to find the values of these 6 trigonometric functions for the angle here theta. So I want to go through and I want to label each of these sides. I know that the longest side here must be my hypotenuse. The side length here that is beside my angle theta must be my adjacent, which means what I have left over is my opposite. So now that I have these 3 sides, I can use my 6 trigonometric functions, and I can say that, for example, my sine of theta, we can see up here is my opposite over my hypotenuse. So we'll say O over A, and that means it's going to be equal to 8 over 17. We can see that my cosine of theta is going to be equal to my A over, this should have been an H. My A divided by H, which is 15 over 17. And my tangent of theta is going to be equal to my opposite divided by my adjacent, which is going to be 8 divided by 15. So what I'd like you to do now is to pause the video, and I'd like you to find the 3 reciprocal trig functions. So I want you to find the cosecant of theta, the secant of theta, and the cotangent of theta. So pause the video now. Okay, so here are my 3 reciprocal trig functions. As you can see, I flipped the fraction. So if I had tangent is opposite over adjacent, I can find my cotangent by doing adjacent over opposite, or simply by flipping this fraction upside down. Now, question 2 says, if sine theta is equal to 5 over 8, says find the exact values of the cosine theta and tangent of theta. Now, this thing here says to find the exact value. An exact value does not mean an approximation. So if you're thinking about using kind of an inverse sign, which we'll get to in a little bit, that's not quite going to work because there'll be some rounding errors. But what we can do is we can draw a triangle. Like so. So we can draw a triangle, and we'll just note that it is a right angle. And we can pick any side we want to be theta. So let's, for example, I'll pick this angle here, theta. And what we've been told here is that my sine of theta, and we know in general that my sine of theta is my opposite divided by my hypotenuse. We know it's equal to 5/8. So what we can say here is we could say that my hypotenuse is 8, and we could say that my opposite is 5. So how do we go ahead and find my adjacent? Well, we would have to use the Pythagorean theorem. So if you can think back to the idea of the Pythagorean theorem, we're going to come here and we can say that a squared plus b squared is equal to c squared, which is my Pythagorean theorem, where c is always the hypotenuse. So we can have my capital A for my adjacent plus 5 squared is equal to 8 squared, which means that a squared is equal to 39. And over here, we can say then that a is equal to the square root of 39. Remember, the question asks for an exact value, so we don't want to approximate. So if I now want to go ahead and find my cosine and tangent of theta, we know that my cosine of theta is equal to my adjacent, or we'll just say my a over h. So that's going to be equal to the square root of 39 divided by my hypotenuse, which is 8. So pause the video now, and I'd like you to find the tangent of theta. Okay, and here is my tangent of theta with the exact values. What we're going to do now is we're going to look at these things which we call special triangles, and you probably would have seen this last year or earlier this year when you went to geometry. The idea of the special angles is there are certain angles in trigonometry that we often care about, and we want to be able to find the exact values. We don't like approximations, we want the exact values. And these often special triangles that we like, they often have kind of names. So our first one we're going to look at is this is going to be, let's kind of move this up a little bit so I have a bit more space. Our first triangle we'll look at is sometimes called the 45, 45, 90 triangle. And I'm going to show you the method that how you could remember these angles, because you are going to be expected on the test to memorize these angles or memorize these triangles. And so in case you forget, I want to show you how to do it. So what we're going to do is we're going to consider a square with a side length measuring 1. So that means because it's a square, we know that these are all right angles. And also because it's a square, we know that all the side lengths are all equal with a side length of 1. And then what we're going to do is we're going to take this side length and we're going to cut it in half. Or we're going to take the square and cut it right down the middle. And we're going to create a triangle. And what happens when we create the triangle? Well, we're still going to have this right angle here. And this length here is still going to be 1. And this length here is still going to be 1. And what we're going to know is because we cut this right angle in half, this must be a 45-degree angle. And this must be a 45-degree angle as well. And so now if we want to, we can use the Pythagorean theorem that says my side length squared plus my side length squared is equal to my hypotenuse squared. So we find out that my hypotenuse is going to be the square root of 2. So this is my special triangle, which has side lengths of 1, 1, and square root of 2. And so if I want to find, for example, the sine of 45 degrees, I know it's going to be equal to my opposite divided by my hypotenuse, which is going to be 1 over root 2, which for the most case I will accept. But something to note is that sometimes in math, we don't like to have a radical in my denominator. So we need to do what's called rationalizing the denominator. And the way that we do that is we will multiply top and bottom by the square root of 2 over the square root of 2. And we'll know that this works out because this value here is 1. And when I do this, I end up having the square root 2 over 2. So this here is my sine of 45 degrees, which is an exact value. What I'd like to do now is I want you to go through, and I also want you to find out the cosine of 45 degrees, as well as the tangent of 45 degrees. And here's my cosine of 45 and my tangent of 45. Note that for this specific angle, my sine of 45 is going to be equal to my cosine of 45. So this is our first special triangle. And our second special triangle we're going to look at is an equilateral triangle with side lengths all measuring 2. Now, if you can recall, for an equilateral triangle, one of the requirements is that all the angles internally must be 60 degrees. And so what we're going to do right now is the same thing as before, as we're going to take this triangle and we are going to cut it in half. And we'll look at, say, the top side. So what do we know about my top side? Well, we know the side length is 2, because my side length here is 2. And we know this angle here is 60 degrees. And by cutting it in half, we now have a 90-degree angle there. There's a couple ways that we could also find this third angle. We know we've cut 60 in 2, so that should be 1/2 of 60. But we also know all 3 angles in a triangle have to add to 180. So this is going to be a 30-degree angle, which is why sometimes this is called a 30, 60, 90 triangle. And then what about the side lengths? Well, if this whole length is here is 2, then half of it should be 1. So this should be 1. And then using the Pythagorean theorem, I'll skip the work for you, but we can find out that this side length here is a square root of 3. So what I'm going to have you do right now, I would like you to pause the video, and I want you to find the sine, cosine, and tangent of 30 degrees and of 60 degrees. I'm not necessarily going to ask you in the ed puzzle to show me all of them, but I do want you to find them. So pause the video now. And here are the answers. We can note that, again, if we wanted to go through and find the reciprocal, all we would need to do is take my fraction and flip it upside down. And one thing I want you to note here is you'll note that the sine of 30 is equal to the cosine of 60, and the cosine of 30 is equal to the sine of 60. So now that we have this in mind, I want you to go through and I want you to pause the video and I want you to try and find the exact value of x. Now, note in this question, we've already found out, for example, we have a 30-degree angle, which is theta, and we've already found out my sine, cosine, and tangent. So I want you to try this question on your own. If you can't get it, don't worry about skipping this question, but do your best. Okay, so for a question like this, I have my angle here, which is 30 degrees. So I'm going to go through and just label my sides to make things easier for me. So I have my hypotenuse, I have my adjacent, and I have my opposite. And so I can see here I want to find my adjacent, and I know my hypotenuse. So I'm going to look at what fraction or what sign or what trig ratio involves my h and my a, and it turns out it's going to be cosine. So I can say here that I know, where am I doing? Here, I can say here that I know my cosine of 30 degrees is equal to my adjacent divided by my hypotenuse. And I'll fill in what we know. We know from above that my cosine of 30 degrees is root 3 over 2. So we can replace that on the right and the left-hand side. And on the right-hand side, my adjacent is x, and my hypotenuse is 8. And so now we want to solve for x. So we're going to get over here. We can multiply both sides by 8. And so we'd have here 8 root 3 over 2 is equal to x, which means therefore x is equal to 4 square root of 3. Now, again, you could use your calculator to solve these questions, but I do want to note that when the question asks for the exact value, it does not mean an approximation or something that has been rounded. So if you were to go ahead and put this all in your calculator and get a decimal, and you put that out here, you would not get the full marks. I am looking for exact value, which requires you to use things like radicals for square root of 3. And then lastly, one of the last things I want to do is look at these things called inverse trig ratios. So an inverse trig ratio is kind of how we can undo a sine, a cosine, or a tangent. So kind of the idea of an inverse is kind of how like a log is an inverse of an exponential, or a square root is an inverse of a square. We have these things called inverse trig ratios, which are going to undo things. So for example, if I have the sine of A is equal to X, I can kind of swap things, and I could say then that my sine of the inverse of X is going to be equal to the angle A, or the measure of the angle A. Now, sometimes we use sine with this -1 here, but I will note, just for your own knowledge, is that sometimes we also have these other words, and that we will sometimes call them arc sine, arc cos, or arc cosine, and we have arc tan. So these are sometimes called our inverse trig ratios. And how exactly do we use it? So here it says, let's go ahead and find the measure of angle n. And this here means find the measure of angle n. So I'm trying to find this angle right here, which means that I know this is my hypotenuse, I know this is my adjacent, and I know this is my opposite. We can see in this question, we've been given the values of h and the values of m, but not the value of a. So I'm going to look at my trig ratio that has the o and the h. So we can see here that my sine has sine of an angle. So we'll say, let's call this angle theta, just because we like theta. So we can say here that the sine of theta is equal to my opposite divided by my hypotenuse. So we would get that my sine of theta is equal to 6/10. Now, what's really happening as to how we get this answer is, if you think about it, if we had something like, and don't worry about writing this down, we had x squared is equal to 4. Well, how do we solve this? We really take the square root of both sides, and the square root and the square kind of cancel out. So what we're really doing is we are taking the sine inverse, or the arc sine, of both sides. And what's happening is this sine inverse and this sine are canceling out. And so we just get here that my angle theta is equal to the sine inverse of 6/10. And you'll need to use your calculator to do this. And we would find out then that theta is equal to 36.9 degrees. One thing that I do want to note, even though we have this -1 here for my inverse, I do want to note that the sine inverse of x does not equal 1 over sine of x. These are not the same thing, so please be aware of that. Okay, so now we can use this idea of inverse trig functions to solve questions involving angles of elevation and depression. And so these are more for realistic or real life questions. An angle of elevation is the angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. So kind of going up. So elevate, so if we have a horizontal line and this object above you, an angle of elevation is if we look at that angle, look at that object, and we measure the angle from the horizontal upwards. An angle of depression is a similar idea, except the object is below you, so we're going to look down. So let's look at a question here. So it says, Sally wants to visit the castle at Disneyland during spring break. She looks at the top of the castle at an angle of elevation of 38 degrees, and she knows that the castle is 190 feet tall. If Sally is 5.5 feet tall, how far is she standing from the castle to the nearest foot? In questions like this, it's always helpful to try and draw a diagram. Now, you don't need to be an artist, just do your very best. So what I'll do here is I'll draw a small little diagram. So we've got Sally standing off here to the side. And we've got way over here, we'll say this is my magic castle. Like this. And so what we're being told here is we are really trying to find what is this distance here that's between Sally and the castle. is really what I'm trying to find. So what do we know? I am trying to find this distance here, which is the horizontal distance to the castle. We know that she looks up to the top of the castle, and if she looks up, she has an angle of elevation of 38 degrees. And we know this is kind of going to be making a right-angled triangle. So let's start filling in what we know. We know Sally herself is 5.5 feet tall, and we know the entirety of the castle is 190 feet tall. So really, we're really trying to find this thing here, which I'm going to call x. So what I'll say here is I'll say, let's let x be the horizontal distance to the castle. And I want you to go through and I want you to find x. So I want you to pause the video now and try this question on your own. Okay, so as I try this question, I see that I have a right angle triangle where I have an opposite, I have an adjacent, and I have a hypotenuse. Now in this case here, my opposite is not going to be 190 because the line of sight is from her eyes. So we're going to say here that my opposite length is not actually 190, but it's going to be 190 minus the 5.5, which is 184.5. So really, we have this right angle triangle. If we really think about it, we have this right angle triangle where we have x here, which is what we're trying to find. We have an opposite height of 184.5, and we have a 38-degree angle. And because we do not have my hypotenuse, but we have my opposite and we have my adjacent, I'm looking for the trig ratio that involves my opposite and my adjacent, and that's going to end up being my tangent. So we can say that my tangent of theta is my opposite over my adjacent. So my tangent of 38 degrees, which is my angle, is 184.5 divided by x. So now we want to solve for x. So by solving for x, we can kind of cross multiply or swap the locations of this tan 38 and this x. And we would get then that x is equal to 184.5 over the tangent of 38 degrees. And I'll stick this all into my calculator. And this would tell me that approximately my x value rounded to the nearest foot is 236 feet. So I can say here, therefore, Sally is 236 feet from the castle. Okay, so that's the video. The homework is posted online. It's all of lesson 7.1, and hopefully this should all be a review from you. If you have any questions, please feel free to send me an email and we can talk, or I'll see you in the Zoom call. Have a good day.